Okay, these problems we're looking at nonlinear systems. So we're going to have two equations and we're going to be solving them and getting answers for both x and y. So these are also can be looked at graphically, but we're going to primarily focus on the algebra, but I will show how it relates to the graph. So the big idea here is you want to use substitution to solve. So we have both equations with x and y, and what we need to do is solve one of the equations right here to make sure they're both either like y equals, or to solve for x and replace it. But our choice we use it for is very important. So we want to make sure that we plug in something that's going to be easy to work with. So one choice I can do is to take this right here and solve this equation for y, and then take the 7 minus x and plug it in up here. Okay, so I get 7 minus x is equal to x squared plus 2x minus 3. Again, we have a square, so I'm going to move everything to one side. So I get 0 equals x squared plus 3x minus 10. Now we could have also at the very beginning, instead, we could have taken the x squared plus 2x minus 3 and simply replaced the y here, and I could have had x plus x squared plus 2x minus 3 equals 7. So to try to make it as easy as possible, it depends on what you kind of see. Okay, this one factors to x plus 5, x minus 2. So now we've got x equals negative 5 and x equals 2. So now what I'm going to do is actually find the points of intersection of this parabola and this line. So to do this, we're going to take this number, x equals now negative 5, and replace the x over here. So I get 7 minus negative 5. That gives me 12. So I get negative 5 12. Then I have x equals 2. I'm going to plug it in to this equation. I get 7 minus 2, and that's equal to 5. So what it shows us is if I graph these, this is the parabola x squared plus 2x minus 3. That's shown in magenta right here. And then we have a line which is x plus y plus 7 equals 7. And we can see that the intersection points are here and here. So those are the points we actually had found. I'm going to change colors. Hard to see the purple. Okay, so let's look at another example. Now this one I'm saying be careful because you have to be a little bit careful sometimes when you're working with it. Okay, so we have x squared plus y squared equals 20, and I have x equals y plus 2. Well, I've already got this solved for x, so I'm going to take the y plus 2 and plug it into the x right here. But I've got to be careful. Really common mistake that students do is they think this is y squared plus 4, but it's not. I'm going to do y plus 2 times y plus 2. So you could look at it as like a rectangle. And if you think about what you have, we have y plus 2, y plus 2. I get y squared. I'm going to have y times 2, that's 2y. Y times 2, that's 2y. 2 times 2 is 4. So I get y squared plus 4y, and this is the part that people always tend to miss, plus 4. So that's when you're squaring it. So be careful. Now there's a shortcut to squaring. It's the first term times itself, that's y squared. Multiply these two together, that's 2y, and double it, gives me 4y. Last term times itself. That's a shortcut for squaring. Okay, so now I'm going to gather my terms. I get 2y squared plus 4y, and I'm going to subtract the 20 at the same time. Now I'm going to factor. First, notice how they're all even, so I'll do factor out of 2. And then y squared plus 2y minus 8, well, I can factor this to y plus 4, y minus 2. So I get y equals negative 4 and y equals 2. So again, this is another spot to be careful. I've got to find the points of intersection. So I've got y equals negative 4. I replace the negative 4 in for y, I get negative 4 plus 2, x equals negative 2. So my point is negative 2, negative 4, not negative 4, negative 2. You got to be aware of what you're plugging in, because it's really easy to think I'm plugging in for x when in fact I'm plugging in for y. Now I'm going to plug in y equals 2. When I plug in y equals 2, I get 2 plus 2 is 4. So I get the point 4 comma 2. So if we look at this, we have a circle. Wouldn't be that easy to graph, but it'd be a circle with a radius as a square root of 20, which is around 4.5. Then of course we have, this is actually still a line. If I went over solved, it'd be the same as y equals x minus 2, which we could have used instead if you felt like it. But this is the graph we have. Okay, one last example. So this time we have a circle and a parabola. Now, the temptation is, oh, I can take the x squared minus 5 and plug it in for the y. It will work, but when I square this, I'm going to get an x to the 4th. It works, it's just not easy. So it's going to be a lot harder. So if we think first and think, well, what if I solved instead for x squared? So I've got x squared equals y plus 5. And I replace the x squared here with y plus 5. Now I've got a quadratic, and we know how to deal with quadratics. So just putting things in the correct order, y squared plus y, subtract the 25. This factors to y plus 4. I'm sorry, y plus 5 and y minus 4. So I get y equals negative 5 and y equals 4. Okay, now I'm going to try to figure out what x is. So if y equals negative 5, I could plug it in right here. Now I get x squared is equal to 0. Therefore, x equals 0. So first point I would have is 0, negative 5. Now I'll plug the 4 in, and I get x squared is equal to 4 plus 5, so I get x squared equals 9. But you've got to be careful here. When I take the square root, I got to do plus or minus 3. Because reason why we take this, because it could be either 3 times 3 or negative 3 times negative 3. So therefore, I get 2 points from that one. So my points of intersection are 0, negative 5. Then we get 3, 4, and negative 3, 4. So if we looked at the graph, it has 3 points of intersection. Here was a 0, 5. Here is the point right here, was 3, 4. And over here, we had negative 3, 4. Not a bad idea to think about what kinds of solutions we can have. This has 3 solutions. Parabola intersecting a circle could have as many as 4. Could have just 2. It could just have 1 or even none. It didn't intersect at all.